Welcome to day one of polar coordinates, or the polar unit. So for our polar unit, we are going to start off with just looking at rectangular coordinates and polar coordinates. So in rectangular, hopefully everyone remembers, this goes x then y. So when you graph it, you go 2, this is the x-axis, this is the y-axis, 2 in the x direction, 4 in the y direction. For negatives, you go in the negative direction. So -3, 1, 2, 3, 4, a little bit off the graph. So we'd have -3, -5. Hopefully that was a refresher for everyone. Polar might be different. So I'd like you to try this on your own first if you want to pause it and then see what I do. So what you're going to do is, based on your guess, maybe you guessed that 2 is going to be like the number of circles you count out, and the degrees is how many degrees in the unit circle you go. So 2, we're going to go 2 circles out and then go to 45 degrees. And that is the point to 45 degrees. What these stand for, 2 is my radius, so 2 is my r, and 45 is my theta. So r, we call our directed distance. I think about it as my radius. And theta is our directed angle. So for example, 3, -120, you're going to count out to 3. So 1, 2, 3, and then we're going to go in the negative direction. So we're going to go -120 degrees. So we're going to hit about here. So that would be the 3, -120. So looking at our polar coordinates, so all of these, in each of these situations, this is r, this is theta. So just like we did on the last graph, I'm going to graph each of these. So for 3, I'm going to count out to 3, and then I'm going to go to 5 pi over 6. So 1 pi over 6, 2 pi over 6, 3, 4, 5. So 5 pi over 6. So this is the point 3, 5 pi over 6. For 4, -pi over 4, I'm going to count out 1, 2, 3, 4, and go in the -pi over 4 direction. So that'd be my 4, -pi over 4. For -20, so now you can see our r has changed from a positive number to a negative number. So my r is now negative. So instead of counting out 2 circles in the positive direction, I'm going to now count out 2 rings in the negative direction. And then my degrees is 0, so I'm just going to have my point be on the 0. It's a little bit easier to see when I have an angle. So on this one, I've got -3, -pi over 3. So I'm going to count out -3, so I'm going to go 3 rings in the negative direction. So 1, 2, 3. And then the negative direction, even when I was starting on the positive side, my negative direction is going clockwise. So that's going in the negative direction, whereas going this way is the positive direction. Same with negatives. Even if I start on the negative side, this is still continuing in that clockwise motion. So that's my negative direction. And going in the counterclockwise direction is going in my positive direction. So I'm going to count out to 1, 2, 3, and then I'm going to go in the -pi over 3. So I'm going to go pi over 6, pi over 4. This is be my -pi over 3. So regardless of whether you started a positive r or a negative r, either way, you're going to be, the positive direction will be in counterclockwise, negative direction will be clockwise. The next thing we're going to look at is writing equivalent expressions. So if I were to graph 3, 5 pi over 6, I'd count 1, 2, 3, and go to 5 pi over 6. So that would be here. So that's my 3, 5 pi over 6. It's asked us to write 3 equivalent expressions, one with a negative r and a positive theta, a positive r and negative theta, and a negative r and a negative theta. And all of them are going to hit this exact same point. So these are within the bounds of -2 pi to +2 pi. So let's start with, let's do -3. So if I start at -3, my easiest one that I can see is if I go in the negative direction of pi over 6, that'll hit the same dot. So -3, pi over 6 would hit the exact same spot. If I did the other -3, I would be at -3 and I'd have to go all the way around the circle to here. So I know making a full circle is going to be 11 pi over 6. So here we're going to have 11 pi over 6. And that was in the positive direction because I was going counterclockwise. And then the last one, we need one more for positive 3. We've already done a positive r and a positive theta, so now we need to do positive r and a negative theta. So we're going to go 1, 2, 3, and then we're going to see how far it takes to get here. So that would be 7 pi over 6. We're going in the negative direction, so it's negative 7 pi over 6. So why don't you guys try the next one before I tell you? So pause the video, try it, then restart the video, and follow along. So I'm going to start with graphing my 1, 2, 3, 4 to negative pi over 4. Then I'm going to try to find all the other ones. So I know I'm going to need to do a negative 4, a negative 4, and a positive 4. So with my positive 4, I'd be looping all the way around until I was back in this quadrant. So that would be 7 pi over 4? Yeah, 7 pi over 4. With negative 4, 1, 2, 3, 4, I'm trying to figure out what's my positive direction getting here and my negative. So my positive direction, 1 pi over 4, 2 pi over 4, 3 pi over 4. So I'd be going positive 3 pi over 4. If I was going in the negative direction, I'd be going all the way around to here. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So going in the negative 5 pi over 4 direction. On your homework, you're going to have multiple problems where if you look in the homework calendar, I changed the instructions to say, find like the equivalent representations maybe between negative 2 pi and 2 pi. So I think in the book it asks you to find all the representations. I just want these 4. So I want you to find the 4 that lie within negative 2 pi and 2 pi. Another aspect of polar is we're going to be converting between rectangular and polar. So if we were thinking just like a normal circle, so we have a unit circle and we have a triangle on the unit circle. We know that this is our x value, this is our y value, and this is like my radius, this is my r, and there's my theta. So if I wanted to find cosine of that angle, cosine is adjacent over hypotenuse, so x over r. So I wanted to get x by itself, I'd have x equals r cosine theta. So notice this side is rectangular, this side is in polar, so that is one of my conversions. So x equals r cosine theta. So that's one way we can do a conversion. If I had done sine instead, so sine theta equals opposite over hypotenuse. So that means r sine theta equals y. So once again, right side's in rectangular, left side's in polar. So my next conversion is y equals r sine theta. If I had wanted to do tangent, tangent theta is opposite over adjacent, so y over x. So this side's already rectangular, this side's polar, so that's a third one we can use. And the final one, if I were doing Pythagorean theorem, I'd have x squared plus y squared equals r squared. Once again, left side's rectangular, right side's polar, so that can help us do conversions. So we're going to see how this helps us on the next slide. So it wants us to plot the coordinates, then convert it from polar to rectangular form. So let's start with number 1. So for number 1, I'm going to go to 3, so 1, 2, 3, and then 5 pi over 4. So 1 pi over 4, 2, 3, 4, 5. So 5 pi over 4 is here. And it's wondering what my rectangular coordinates are for that. So rectangular coordinates, I know that x equals r cosine theta. And fancily enough, they've given us the r and the theta, so I can plug them in. So x is going to equal 3 cosine 5 pi over 4. So x equals 3 times root 2 over 2. And in this quadrant, cosine is negative. So x is negative 3 root 2 over 2. If I wanted to find y would be r sine theta. So you'd have y equals 3 sine 5 pi over 4. So 3 times negative root 2 over 2 again. So y equals negative 3 root 2 over 2. So in the end, my rectangular coordinates are going to be negative 3 root 2 over 2 and negative 3 root 2 over 2. So that would be, if I had graphed rectangularly, those coordinates would be the negative 3 over 2, or negative 3 root 2 over 2, and negative 3 root 2 over 2. So why don't you guys try the next one on your own before you watch the video? So pause it and then start it again. So doing it again, we've got x equals negative 2 cosine negative pi over 3. Oh, I forgot to graph it. Let's graph it first. So negative 2, and then in the negative pi over 3. So we should be here. So we are now finding the coordinates for this triangle. So x equals negative 2 cosine of pi over 3 is 1/2. Yep. And in that quadrant, all students, so it should be negative because, actually, let me think for a second. So actually, this should be a positive 1/2. The reason why is because when we evaluate this negative pi over 3, we are thinking about in a unit circle normally, where is cosine negative pi over 3. So normally that is down here in this fourth quadrant. And in the fourth quadrant, all students take calculus, cosine is positive. So that's why we're going to get a positive 1/2 here. So that'll end up equaling negative 1. So our x is negative 1. So I wrote myself a note because I get confused because I saw this dot in this quadrant, so I thought cosine should be positive, but really I'm evaluating cosine in the original quadrant on the unit circle. So if you need to write yourself a note, I wrote myself a note that said evaluate using unit circle. Then for the y, we have negative 2 sine negative pi over 3. So we've got negative 2 times root 3 over 2. And in the fourth quadrant, that would be negative. So we end up with the 2's cancel, so we end up with a positive root 3. So my rectangular coordinates here are negative 1 root 3. So on the homework, when it asks you to convert from polar to rectangular, that's the method that I would use. The flip side of that is converting from rectangular to polar. So if they'd given us the rectangular point negative 4, 0, this is my x and my y now. If I go out to negative 4, 0, if I had drawn the circles, so these are going to be kind of sketchy circles. Notice each of the circles, well, I'm trying to make them hit at the fourth circle should be hitting at all the 4s. The third circle should be hitting at all the 3s. So notice your circle is hitting, this is on the fourth circle. So my r is going to be that negative 4, or r is going to be 4 because I'm on the fourth circle. And then we are going to write all of the different coordinates that are between negative 2 pi and 2 pi, just like we did earlier in the notes. So we are going to do positive 4 and another positive 4's point, and then we're going to do the negative 4 point and the negative 4 point. So if I had started at positive 4 and I wanted to get all the way over here, I had gone pi. If I was going negative 4, I could just be at 0. For another positive 4, I could be going in the negative pi direction. And for negative 4, I could be going a whole negative 2 pi around. So those would be 4 coordinates between negative 2 pi and 2 pi that all hit at that same spot. 2, 2 is a little bit trickier. We just have to think about it more. So if we had done 2, 2, so 1, 2, 1, 2. So we are looking for what is, I know it looks like